One more quick thing that I'll show you that's very closely related are just a couple of additional terms to be aware of. Theoretical yield is a product mass from a stoichiometry calculation. So going right back to our last page, this product mass that we made here, that is our theoretical yield. So let's write that right there. If we calculate the amount of product that we are able to form, that is called a theoretical yield. So let's just write right here, 27.3 grams of P2O5 from the last page. Okay, so it's very common when we're performing a reaction to take the amounts that we use to calculate a theoretical yield so that we can know how much product to expect. Now the thing is, in the lab, the isolated product mass from a real reaction in a real lab is always smaller than the theoretical yield. Okay? This is called actual yield. If we were to go into the laboratory, if the reaction produced a solid product, say, we'd probably filter it out and then scrape it out onto some weighing paper and then measure the mass of the product we created. It is impossible for us to get the theoretical yield. Okay? We're always going to get less for some reason. Sometimes not all of the limiting reactant reacts. Sometimes we lose some products from one way or another in transfers or something. Sometimes some of it stays stuck into the container and we can't quite scrape it all out. Sometimes it might fly away or something like that. So in the real world, it is impossible to get fully the theoretical yield, at least for a pure product. That's right, for a pure product. Say we're sure that our product is pure, there's no way that we will get all the way up to the theoretical yield. This is a limit that we can approach, in other words. It's actually even worse. Say that our theoretical yield here was 27.3 grams of P2O5, and we did this reaction, and we got 35 grams of some product. Well, what happened there? Did we miraculously violate the law of conservation of mass? No, I don't think so. That's actually a little bit worse because, let's write right here, higher actual yields may indicate an impure product. Say this product that we're scraping out of here, if we had assumed it was all product, that might be one thing, but maybe there's still some of the leftover reactant in there. Okay? That's not a good thing. That indicates that our product is impure. We would have to purify it one way or another, and then we would have some sort of more normal actual yield in that case. Or there could be some solvent left over, or some water or something that hasn't been dried out. So what we can do then is compare the actual yield and theoretical yield as a percent. Percent yield is just actual divided by theoretical and times 100%. That is the same way that you would calculate an exam score or something like that. Your actual points divided by the theoretical number of points times 100%. So just a way of assessing how efficient you were in getting your getting the reaction to go to completion and isolating a purified product. So let's say that the actual yield of the previous reaction was 25.2 grams of P2O5. What was the percent yield? We had calculated the theoretical as 27.3 grams, so all we have to do is do 25.2 grams divided by 27.3 grams. The actual yield, you'd have to be given that in a problem, unless you were to go to the lab and do the reaction yourself on an exam or assignment or something. You'd have to be told what the actual yield was. If we did that, it would just be a fraction out of 1, so we have to do times 100% to make a percent out of it. So I got 92.3%, which, especially maybe for a student, that would be an outstanding yield. if you ever go on to take more chemistry classes, a lot of times in lab, the last thing you'll do is measure the mass of the product that you created and compare it with the theoretical yield that you calculated, and that's a way of assessing how efficiently your reaction did. So especially students that are just sort of getting started might be just totally fine with 60 or 70% yield, and that's what we're expecting. In industry, where lost yield is lost money, they try to get things 95 or 98% or even more like that. But it has to be a purified product in order for that number to be meaningful. You will also sometimes see this type of question tacked on to a limiting reactant question, like the previous one. It could just be a matter of saying 25.2 grams of P2O5 are formed. What is the percent yield? Well, to do that, though, first you'd have to go through the calculation we did before, starting with each of your reactants, using the smaller answer to figure out theoretically how much we could possibly get. And then you can take your actual divided by theoretical. Okay? So that's it for this video. We'll have more practice on that. Why don't you save these ones for class? We'll work on these together in your groups during class next time. If you want extra practice on this, though, go to the practice worksheets in D2L. The second half of that mole calculations and stoichiometry worksheet has several questions involving gram-to-gram calculations as well as limiting reactant type calculations. So you should be able to get plenty of practice there.